Topic 2, we examine the nature of evolutionary explanations. In this first lecture, we examine what is a theory. We'll start off with several standard definitions of theory before we turn to the idea that a theory is simply a level of explanation. We'll then consider what a theory is not before we turn to an example of an evolutionary explanation. This section of the course includes 13 key terms and concepts. We'll divide these terms and concepts into 4 parts, each represented by their own lecture. Today, we'll begin with Part 1. Let's start by looking at some standard definitions of theory. Kurt Lewin, who is often recognized as the founder of social psychology, once said, "There is nothing so practical as a good theory." However, as evolutionary psychologist Gerd Gigerenzer notes, the problem is not that a majority of researchers would say that theory is irrelevant. The problem is that almost anything passes as a theory. Emeritus Professor of Philosophy Harry J. Frankfurt once said, "Bullshit can be defined as a communicative act whereby the words or deeds of the actor are designed to produce some impression upon the mind of the audience with little or no concern for the validity of what is being communicated." Theories in science differ from bullshit precisely because the theories that scientists create aim at constructing valid explanations. By contrast with scientists, lay people often use the term theory to refer to any explanation that is untested or untestable. Claiming that theories are simply untested explanations erroneously suggests that theories become true when they are tested. On the other hand, claiming that theories are simply untestable explanations confuses theories with mere opinions. Unfortunately, even social scientists sometimes use the term theory in a misleading way. For some social scientists, a theory is simply any explanation that is A, the product of hard work, B, involves a series of related studies, and C, is sophisticated or just plain complicated. Yet none of these elements are necessary for an explanation to be considered a scientific theory. So just what is a theory? Let's consider several technical definitions. A dictionary definition of theory might define theory as a supposition or a system of ideas intended to explain something, especially one based on general principles independent of the thing to be explained, such as Darwin's theory of evolution. In philosophy of science, there are 2 main views of the nature of theories. According to the received view, theories are partially interpreted axiomatic systems. According to the semantic view, a theory is merely a collection of models. So what do we mean by saying that theories are partially interpreted axiomatic systems? What is an axiomatic system? Stanley Schachter, a student enrolled in Kurt Lewin's graduate course on social psychology, once described Lewin's course as more philosophy of science than a review of different theories. Following in William James' footsteps, Kurt Lewin argued that if social psychologists wanted to become sophisticated social scientists, they too would have to start behaving more like natural scientists, such as physicists and chemists. Lewin's influence on social psychology gave rise to 2 important legacies. One legacy inspired social psychologists to become ever more capable experimentalists. The other legacy urged them to become more sophisticated theoreticians. Jerome Singer, a student of Stanley Schachter, and thus an academic grandson of Lewin, noted, "The basic steps in conducting Lewinian-based research were to set up an axiom system from which were derived theories and correlates. Each derivation became a statement subject to experimental test." One way to think about how to derive theorems and correlates from a set of axioms is to consider Cattell's inductive hypothetical deductive spiral. In his edited book, The Handbook of Multivariate Experimental Psychology, Raymond Cattell described the scientific method as an inductive hypothetical deductive spiral. For Cattell, the scientific method began with an experimental observation. This led to inductive reasoning to infer some regularity about the world. This in turn led to a hypothesis. The hypothesis then provided the ability to deduce consequences that could be observed in an experiment. This led to yet another experimental observation that led to yet another induction, another hypothesis, and another deduction. Cattell's understanding of the scientific method thus offers a familiar definition of theory. For Cattell, a theory is the sum total at a given time of our organized understanding and predictive power, our capacity to explain in the given area. Cattell argued that by a law, we mean a statement of a regular relation. Theories usually grow, said Cattell, or can best grow, from integration of collections of laws. And at some point, a collection of explanatory laws, maybe only 2 or 3, becomes appropriately renamed a theory. Let's turn now to look at how a theory is a level of explanation in science.